In this video, we will be graphing the transformations of quadratic functions. So our quadratic function in vertex form is y is equal to a times x minus d squared plus c, or it can be seen as y is equal to a times k times x minus d squared plus c. The a value shows a reflection in the x-axis when a is less than 0, so when a is a negative number, but it also shows a vertical compression or a stretch. The d value shows a horizontal shift, so it moves the parabola left or right. The c value at the end here is a vertical shift and moves our parabola up or down. And if we have a k value, so the k value is inside these brackets before we square it. It's a reflection in the y-axis when k is less than 0, so that means k is negative, and it also shows a horizontal stretch or compression. Now the k value and the d value inside these brackets before it's being squared, these affect your x values directly, and then our a value and our c value will be affecting the y values directly. Our quadratic that we're going to graph is y equals 2 times x minus 4 squared minus 3. Now let's start off with our parent function, y equals x squared. Let's just make a table of values to observe our points in this parabola. So if we use the x values -2, -1, 0, 1, and 2, our corresponding y values would be 4, 1, 0, 1, and 4. And if we plot these points, we can start off with our vertex of this parabola, and then we're going to go over 1 and up 1 to our next point, over 2 and up 4 to our third point, and then it's just a reflection in that y-axis. So our equation is in vertex form, so we can identify the vertex right away. So remember, it's this h and k value right here. So our vertex is actually 4 and -3. So we can plot that. So our new parabola shifts to the right 4 units and down 3 units. Since we have an a value of 2, that means our parabola is going to be vertically stretched by a factor of 2. So that means our y values are actually going to be multiplied by 2. Now we can use that to apply all of these transformations, but we're going to do it in a type of step pattern. So we're going to keep all of these x values the same. So -2, -1, 0, 1, and 2, because those aren't really changing. And then we're going to multiply all of our y values by 2. So 4 times 2 is 8, 1 times 2 is 2, 0 times 2 is 0, and those repeat. These are not the new coordinates of the new quadratic, it's just a pattern that we're going to follow. For our new vertex 4 and -3, we're going to go over 1, up 2 to our new point, and then we're going to go over 2, up 8 to our next point. And on the other side, it is just a reflection. And this is actually our newly transformed parabola. Now I'm going to show you another way to graph this quadratic by using the transformations and applying them directly to each y and x value. So our equation is y is equal to a times k times x minus d, all that is squared, plus c. We can apply each transformation directly to the x and y values of our original function. So our original points are x and y. Our k value and our d value directly affect our x. So our x value would be divided by k, and then we would add d. Y is being multiplied by a, and then we would add our c value. So in our quadratic equation, K is 1, it will not affect anything. D is 4. Our A value is 2, and C is -3. So if we want to create a new table of values, we need to apply all of those changes to the original values in the parent function. So we're going to add 4 to every x value, and then all of our y values are going to be multiplied by 2, and then we're going to subtract 3. So we're going to apply these transformations to our first point, -2, 4. So -2 plus 4 is 2, positive 2. 4 times 2 is 8, minus 3 is 5. So 2 and 5 is our new point. Now pause the video and try to fill out the rest of the table by applying each transformation to the points of the original graph. So these are our transformed points, and as you can see, if we plot each point, it'll be the exact same graph as our first method. So 2 and 5 is up here, 3 and -1 is here, 4 and -3, 5 and -1, and 6 and 5. So it would be the exact same parabola. So now you have two ways to graph the transformations of a parabola. Practice graphing and use the method that works best for you. So take a moment, try to graph this parabola right here. Pause the video, and then when you're done graphing, come back and see if you've graphed it correctly. And there is our new graph.